because we are about to dive into it. Dive into the question yet again. Let's see. What's that thing? Oh yeah. So it says you determine the gradient of NM, right? I feel like I got distracted, but IM is back. So they want the gradient of NM. We were given this angle of inclination. We're also given this angle of inclination. Okay, technically we're given all these angles here. All these add up to 180. Yeah, we might as well even double check that because they do add up 180, so it's fine. Everything looks fine. What else now? So if we're gonna work out the gradient of NM, the last time we tried to do some crazy angle of inclination stuff at this point over here, you see. But then whatever it is that we were trying to do at this point over here, I wonder what would happen if we try to do it at this point instead. You see, it's just me thinking out loud, you know. Yeah, so let's maybe see what happens if we do it like that. So remember, if we had a straight line here that was parallel to the x-axis, it means that if you're looking at NM, if we extend NM, right, like this, then one way or the other, we can see that if we had this angle of inclination here, we know that we would have a way to get our gradient. So from all the information that we have, right? Yeah, we just have to be, I don't know, we're just gonna try and not play too many games. So what I'm already seeing here is, remember this green line is parallel to the x-axis, right? So if the green line is parallel to the x-axis, do you see that here we have alternating angles?
Yes, I do see.
Yeah, so this is 90 and 33. So this is like 123.69, right? Right.
Yes.
Yes. Okay. So what else do we know? Yeah. I think maybe. Yes, ma'am.
Is it possible to state that since that line is parallel to that line, and say that line is perpendicular, like the line from NO?
Mm-hmm.
Is it okay to say that, or?
Oh, what?
I'm saying the line NO, right? Is it possible to say that it's perpendicular to, no, supplementary to the line, the parallel line?
Well, if you're trying to say these two angles are supplementary because these are parallel lines, yes, that's true. You see, because this plus this still gives us 180. Because these are
co-interior?
Yeah, co-interior angles. So we could have gotten this from saying alternating angles, or from just saying co-interior angles there.
Okay.
Yeah.
Okay.
Nice. Whew, but the pop is still dancing. The doll is still dancing. And it's still like, I wish we had a marker location, because I feel like if we had a marker location, I don't know, man, we could have done something, you know. I feel like we could have done something. But the thing, yeah, so the thing that we also know is that yeah, I feel like we're back at square one again. Like, it's so sad. I don't know if getting the radius of this circle is going to make anything better. Oh, but we have a semicircle, and let's see, an angle subtended by the diameter of a circle is 90 degrees. So then where can we get that kind of a thing going? Let's see, time after time. You're not. Let's see if the equations of these lines will help us. Y2 is equal to negative 3y. So this is like, no, negative 3x. Let's just get those equations again. Because, yeah. So this is going to be y is equal to negative 3 over 2x. I wonder if this x-intercept is going to help us. It might. Let's see. So that's for ON, right? This one is for ON. The other one is for OM. OM, the equation there. Oh, no. No, they all have the same x-intercept, which is this one. I was busy being weird. 2 over 3x, right? Okay, yeah. So we have the two equations of the circle. We know that they meet at one point, and then after meeting there, yeah, they basically just, yeah, they only meet that they only meet at that point, and then that's it. So, yeah. Let's see what else we can try and gather from here. We don't have anything. We don't know anything about M. We don't know anything about N. Yo. I mean, we're busy focusing on this line here and that. I mean, like whatever we have here, we could reconstruct it. I feel like wherever we reconstruct it, it doesn't look like it's really helping. So, yeah. I don't know what the fresh brains are saying, but the fresh brains are not coming up to the party. Because I mean, like if we had something, if we can maybe figure out something in this shape, like in this triangle, maybe somehow get any other angle, we might have some luck. Because all we have is, yeah, it's just a bunch of stuff that's not very helpful. Because I'm like, this whole angle here is the same as the whole thing here, but then that doesn't help with anything. I don't think it helps with anything. Because if that's 50 something point, what, 56.31, yeah, it really doesn't do anything. Oh no, yeah, I thought I got something, but nope. Go back. Get the gradient of NM. Gradient of NM. Oh well, let's see what these last two questions could possibly give us. State why we may conclude that ON is perpendicular to that. Okay, we concluded that. Determine the angle of inclination of OM. This angle of inclination there. Oh. Let's try some funky stuff, you know. So we have ON, and we have this right angle triangle here, right? If we want. And then we also have this right angle triangle here, if we want. These two right angle triangles, they only have one thing in common, which is the radius, which is OM and ON. You see, that's the only thing that's equal. Whatever this is, it's equal to this. So let's see what happens if we label this R and label this R. The two angles, we already have them, right? It's like 33 point something. And then here we have 56.31. Let's see what happens if we do what? We have an angle and a radius. What could we try and get? Okay, let's try and see if we can get this perpendicular height here. Let's label this one Y. Let's label this one U. Good Lord. Yeah, let's label this one what? What could we label this one? X. But it's gonna feel a bit weird. Let's just choose any. U.
Yeah.
Okay. I really don't think what we're doing right now is gonna get anywhere, but hey, you never know. So I just have to do and cry later. So if we had here, let's see, we have opposite over hypotenuse, right? So let's see, sine with the 56.31. I feel like this is also an exaggeration though. opposite over hypotenuse, y over r. And then here we're gonna have the sine 33.69 because u over r. I mean, one way or the other, if we isolate y here, we're gonna have r sine 56.31. Here would have r. This, I mean, this is what y is, right? For the other equation, we would have, let's see, r sine 33.69 equal to u. I don't know if those distances are really helping us much. So we have, oh, so technically this distance here is the y value of our value of n, and the distance here is the y value of our m. Do you see that?
Yes. Wait, is it possible to use trig to find out the angle of n?
You mean this tiny part?
Yes. Or the angle of n.
Yeah, as it stands, right? It doesn't look like we have enough information.
Oh, okay.
Yeah, it doesn't look like we have enough information at all. So that's a bit of a problem, you know, bit of a problem. So yeah, it's scary. It's kind of scary. But then with Pythagoras theorem, I mean, like, whatever we know is that r here and r there, right, is going to give us the distance there. But it doesn't look like the distance here is useful at all, like at all. So yeah, it's a bit of a mess. It's not a small mess. It's a big mess. Because getting the gradient, y something. What does the back of the book say for 3? I don't think we ever checked.
K3. For number 3, it says minus 0,2.
Minus 0,2. That's like what, 20%? 20% is like 2 over 10, which is like 1 over 5. Negative 1 over 5. So the gradient there is like negative 1 over 5. Much lovely. Africa, 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 yeah. Negative 1 over 5, negative 1 over 5, negative 1 over 5, negative 1 over 5. A semicircle with center O is given. ON and ON and OM are chords of the circle. The equation of line ON is this. The equation of OM is this. State why they're perpendicular. We stated why they're perpendicular. And then determine the angle of inclination of OM. We did that easily. And then boom, determine the gradient of MN. Ay. Yeah.
I'm as lost as you are. So
Pardon?
I'm saying I'm as lost as you are, so I don't know what to say.
Yeah. It's one of those moments where that wild card comes out like, something is wrong with the question. They left out something. Yeah. So yeah, I also do think it doesn't help much to be cracking our brains right now. We could just save it, just keep saving it until maybe something clicks. Or also, if you haven't gotten this far in class, like as soon as you see you're close, we can just raise it if we have not yet, let's say, come back to it at some point in time. But you know what you should do? Let me just send this to the group also, just so that people can crack their brains also while we do other things. Hold on. Give me 2 seconds. I just want to find the question when you sent it, and then I will send it to the group. I feel like, let's see here. Let me crop it out so that only this thing is like left. Give me 2 seconds. I'm just cropping out the bottom part. Doing this, doing this, doing that. Done. And then I just want to circle it. And then let's see here. Oh wait. Oh no, I sent it to you. Hold on. I need the group. Smiley face emoji. Flip this to the right. Zoop. Send. Determine the gradient of MN. Let's see. Let me just see. Good luck. Good luck. May the odds forever be in your favor. Yeah, let's leave it for now. Let's let them work it out. If they work it out, nice. If they don't, we shall come